Yeah, good morning students. Today I would like to discuss about graph traversal techniques. So basically there are two types of graph traversal techniques. They are depth first search and breadth first search. Before going to know about depth first search and breadth first search, you have to know what is a graph traversal. In computer science, a graph traversal refers visiting each and every node in a given graph. So we need to visit each and every node in a graph in an order. So to visit that nodes, we have these techniques. They are the breadth first and depth first search. So before going to discuss about BFS and DFS, so I would like to know a few things regarding graphs. First of all, what is a graph? And then what is a directed graph and undirected graph? What is weighted graph and unweighted graph? So before going to know what is a graph, so a graph is a nonlinear data structure which is represented as a z equal to set of v comma e, where this v is represented as set of vertices and e is represented as set of edges, and we can call the vertices as nodes and edges as arcs. So here in a given graph, so we have represented V as set of vertices. So 1, 2, 3, 4, 5, 6. So these are the set of vertices. And coming to edges, so we are going to represent it as E. E equal to set containing, there is an edge between 1 to 4 and 1 to 6, 2 to 6, 4 to 5 and 5 to 6. So we have represented the edges here. And the second question is, what is a directed graph and undirected graph? In undirected graph, there will be no directions for the edges. That means in undirected graph, we can travel from a node 2 to 4, and we can travel from 4 to 2 also. So there has no orientation for the edges in undirected graph. Whereas a directed graph, or we call it as a digraph, in which edges have orientation. That means we can travel from 0 to 1 but not from 1 to 0. So this is the case in a directed graph. Now coming to the weighted graph and unweighted graph. So in weighted graph, the edges are represented with some values. We call these values as weights, or in some cases we call them as a cost or length of the edge. So here this is an unweighted graph which doesn't have any weights for the edges. So this is an unweighted graph and this is an unweighted graph. Whereas here this is a weighted graph where the edge from 2 to 0 is having a weight 5 and an edge from 2 to 1 is having a weight 4. So we call such type of graphs as weighted graphs. Now I would like to discuss about the depth first search algorithm. So this depth first search is based on backtracking algorithm. So before going to discuss about the depth first search, you must know that depth search first algorithm will work for both the directed and undirected graph, and it will work for both weighted and unweighted graphs. So let us take an example. Here this is a graph containing vertices as A, B, C, D, E, F, Z, H. So we have taken a visited array. Here in the visited array we have taken all the vertices in the given graph, and here we have to take a stack. So here in the DFS we use stack data structure, and the first and foremost step for working with the DFS is the first step is you can take any arbitrary node as your starting node. So here I have selected D as my starting node. So with D I am going to proceed. Then the second step is you have to push this D into the stack, and in the visited array you have to mark D as visited. This is the second step. And the third step is so here the stack contains D, because already we have pushed D into the stack. Now you need to find out the adjacent nodes of D in alphabetical order. So here for D, the adjacent nodes are C, E, F in alphabetical order. So we need to find out the adjacent nodes of D. This is step number 3. So we'll start with these 3 steps now. So I am choosing D as my arbitrary node. So we need to push D into the stack, and we have to mark D. So the order of nodes visited is D. First we have visited D. The second step is the topmost element of the stack is D, so we have to find out the adjacent nodes of D. As already said, the adjacent nodes of D are C, E, F. So in alphabetical order, we have to choose C. That means we need to push C into the stack and mark it as visited. See here, I have pushed C into the stack and I have marked C. So the marked nodes are represented in red color. Now the third step is the topmost element is C. So we have to find the adjacent nodes of C. Here in this case for C there are no adjacent nodes. So whenever there are no adjacent nodes for the topmost element of the stack, we need to use backtracking. Backtracking is nothing but we have to pop the topmost element. So here I am going to pop C from the stack. Now whenever you are going to pop C from the stack, the topmost element is D. So now D is the topmost element. We have to find out the unvisited adjacent nodes of D. The adjacent nodes of D are C, E, F, but I said that we have to find out the unvisited adjacent nodes in alphabetical order. The unvisited adjacent nodes of D are E and F. So according to alphabetical order, we have to push E into the stack. So whenever you are going to push E into the stack, mark E as visited. So here E has been visited. Now the third step is you need to find the adjacent nodes for E, because E is the topmost element in the stack. So the adjacent nodes of E are Z. So we need to push Z into the stack and mark Z as visited. Now again the topmost element here is G, so we have to find out the adjacent nodes of G. So the adjacent nodes of G are D, because D is already visited, so we should not consider D. Then the adjacent node is H. So we need to consider only the unvisited adjacent nodes of this element, that is the topmost element. So G is the topmost element. The unvisited adjacent node of Z is H. So push H into the stack and mark it as visited. So I have pushed H into the stack and I have marked here. Now the topmost element of stack is H. This is H. So we have to find out unvisited adjacent nodes of H. So there are two unvisited adjacent nodes for H, A and B. So alphabetically we have to push A into the stack and then mark A as visited. So I have pushed A into the stack and I have marked A as visited. Now the topmost element is A, so you have to find out unvisited adjacent nodes of A, that is B. So push B into the stack and then mark it as listed. Now here the topmost element is B. So now you have to find out unvisited adjacent nodes of B. There are no unvisited adjacent nodes for B. So we need to do backtracking. So backtracking is nothing but pop the topmost element of the stack. So we have to pop B. Now the topmost element is A. Now we need to check again whether there are any unvisited adjacent nodes for A. There are no unvisited adjacent nodes for A. So we have to pop A. And then the topmost element is H. So you need to check whether there are any unvisited nodes of H. There are no unvisited nodes for H. So pop H also. Then the topmost element is G. We need to check whether there are any unvisited nodes for Z. So there are no unvisited adjacent nodes for Z. So pop G. Now the topmost element is E. Again need to check whether there are any unvisited adjacent nodes for E. No, there are no unvisited adjacent nodes for E. So pop E. Now the topmost element is D. So there is one unvisited adjacent node for D, that is F. So we need to push this unvisited adjacent node of D into the stack and mark it as a visited. So I have pushed F into the stack and marked it as a visited. Finally, the DFS of a given graph is D, C, E, G, H, A, B, F. So we have visited all the nodes in a given graph. So this is the working procedure of DFS. Now take this graph as an assignment and work out the DFS for the given graph. Thank you.